This is a video assignment done for the module Programming Languages and Design Concepts of BSc Honours in IT of Sri Lanka Institute of Information Technology in 2016. What is about to discuss here in this video assignment is the comparison of programming languages. Let me introduce our team. It's Sahan Veerakkudi, Bhanuka Samarasinghe, Umra Muzaffar and Sarasi Sumatipala. Now let's begin the tutorial. At first, we should know why we need a comparison. Programming languages are intended for the expression of computer programs and that is capable of expressing any computer program. All programming languages are equally powerful, yet their expressivity differ, hence a comparison is needed. A programming language is a formal constructed language designed to communicate instructions to a machine, particularly a computer. There exist different categorizations for programming languages. Here we have taken the categories I mentioned below: procedural programming languages, object-oriented programming languages, functional programming languages, logical programming languages, and special-purpose programming languages. And how we are going to do the comparison in this tutorial is we are going to choose one language from one category and compare and contrast. Characteristics of a specific language in a category is examined and used thoroughly to compare and contrast the language categories. Now let's discuss the procedural programming languages. Procedural programming is the standard approach used in traditional computer language such as C, Pascal, Fortran, and BASIC. The basic idea is to have a program specify the sequence of steps that implements a particular algorithm. Fortran is the language that is selected from procedural programming languages. It is originally developed by IBM for scientific and engineering applications. Fortran program consists of a main program and 0 or more subprograms. It has two constructs, imperative and declarative, where imperative must be executed at compile time and declarative must be executed at runtime. This is a simple Fortran program. Here, highlighted area contains declarative constructs, that means non-executable constructs. Steps of declaring a declarative is: first you have to allocate a memory, then bind a name to it, finally initialize. In this section, imperative constructs are shown. It can be divided into three categories. They are the computation, flow control, input and output. Fortran syntax. As shown here, Fortran syntax is divided to 5 sections. Here C indicate comments and 1 to 5 line contain statement numbers and 6 line indicates the continuation. The lines 7 to 72 are the statements and from 73 to 80 onwards the sequence number is shown. Fortran control structure. Go to statement was the basic building block for control structure in Fortran. Three types of goto statements are there in Fortran. They are the basic goto, computed goto, and the assign goto statements. Also, Fortran has the if, then, else, and repeat until and while do loops to control the data flow. Fortran language has its own strengths and weaknesses. Strengths are to support numerical and scientific approaches, it is simple enough to become familiar, and the language is straightforward to compile. The weaknesses are that it has a fixed statement layout, lack of reserved words, and weak type checking system. Now let's discuss the object-oriented programming languages. Object-oriented programming (OOP) is a programming language model organized around objects rather than actions and data rather than logic. Historically, a program has been viewed as a logical procedure that takes input data, processes it, and produces output data. Let's take Java, which is ideal to describe object-oriented programming. Java is the most popular language for today. It is a general-purpose computer language which is concurrent, class-based, and object-oriented. It is designed to have a few implementation dependencies as possible, and it introduced the concept of write once, run anywhere. Java program structure. Java has a very simple structure. A Java program consists of a collection of classes and methods but nothing else. Java data types are of two types. They are primitive data types and non-primitive data types. The primitive data types are byte, short, int, long, float, double, char, boolean, while non-primitive data types are the strings and arrays. Java variable declarations. There are a set of rules of declaring Java variables. A variable name can consist of capital letters, lowercase letters, digits, and two special characters, the underscore and the $sign. The first character must be a letter. Blank spaces cannot be used in variable names. Java keywords cannot be used as variable names. Variable definition is like this. First you have to declare a type and then you have to add a variable name. There are three types of variables that could be seen. They are the local variables, instance variables, class or static variables. Local variable is a variable that is declared within the method that is called local variables. A variable that is declared within the class but not in the method is called an instance variable. A variable that is declared with static keyword in the class but not in the method is called as a class variable. Java control structures. There are multiple ways for flow control in Java shown here. Java also has its own strengths and weaknesses. The strengths are large ecosystem of open source tools, applications, etc. The write once, run anywhere concept, and it is called the major contribution of Java. The weaknesses are that it's hard to implement web applications, no separation or specification from implementation, no local constants. Now let us discuss the functional programming languages. Functional programming is a style of building the structure and elements of a computer program that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. It is a declarative programming paradigm, which means programming is done with expressions or declarations. Scheme is the language we have selected to describe under functional programming languages. Scheme uses functional components of LISP. It is generally used for teaching. Scheme data structures. Scheme permits two types of objects, namely atoms and lists. Atoms are also of two types, as numeric atoms and as string atoms. Lists are comprised of sequences of atoms, list separated by blanks and parentheses. Scheme program structures. A scheme program consists of a sequence of expressions and definitions. Expressions are constructs that return a value such as a variable reference, literal, procedure call, or conditional. Definitions are valid in some, but not all, contexts where expressions are allowed. Here are some examples for scheme program structures. There are strengths and weaknesses in scheme language too. It is that it has a simple syntax, few primitive functions from core of language, easy to learn and extend, no side effects, use automatic storage management, basic control structure, conditional expression, high level of abstraction, well suited for parallel machines, programs are very easy to check for validity, and scheme avoids the complexities of temporal reasoning. Weaknesses of scheme language is that it is slower when compared with procedural languages. Now let us move on to logical programming languages. What is logical programming? A program written in a logic programming language is a set of sentences in logical form expressing facts and rules about some problem domain. Prolog is the language we have chosen to describe logical programming languages. Prolog is a general-purpose programming language associated with artificial intelligence and computational linguistics. Prolog program structure has three main parts: the rules and clauses, facts, and query. The rules and clauses has further divided into three categories as hypotheses, goals, and conditions. Prolog data structure. Prolog does not have a fixed set of data structure. Constructors, there is essentially no data structure constructors in Prolog. The data structures are defined purely by their properties. The same approach can be used to define all data. Data structures are formed using compound terms. There's an example shown for a Prolog data structure. Prolog strengths and weaknesses. The strengths are that it's a very high-level language, logic and control separated, easy to prove programs correct, easy to automatically optimize programs. Weaknesses are that it's impure logic programming, cut encourages procedural programming, cut and etc. assist with efficiency of sequential machine, quite inefficient, non-monotonic programs are difficult to verify, possible parallel versions of Prolog. Now let us move on to the special purpose programming languages. A special purpose programming language is a program language that was designed for a specific function. SQL is the language that we use to describe special purpose languages. It stands for Structured Query Language. Standard language for accessing and manipulating databases. Consists of data definition language, data manipulation language, and a data control language. SQL language elements. It has clauses, expressions, predicates, queries, and statements. An example is shown here. SQL queries. The most common operation in SQL, the query makes use of the declarative select statement. Select retrieves data from one or more tables or expressions. Some of the SQL queries are shown here. There are strengths and weaknesses in SQL as well. The strengths are that it's high speed, well-defined standards exist, used with any DBMS system with any vendor, portable, easy to learn and understand. The weaknesses are the difficulty in interfacing and more features implemented in a proprietary way. Conclusion. Every programming language has its pros and cons, and learning them is important because for each situation there would be an ideal language to perform it. This is the end of our video. Thank you.